Hi everyone, my name is Dr. Vile. Welcome to my YouTube channel for A-level chemistry. This channel is all about getting you ready for your A-level chemistry exams. So if you find these videos helpful, please like, please subscribe, please share with your friends, and please keep checking back for more content as I'll be updating the site regularly. This specific video is going to be all about bond enthalpy calculations. So how can you theoretically calculate whether a reaction will be exothermic or endothermic by looking at bond enthalpies. We've got a question. We've got ethine, which is a molecule you're probably not very familiar with. Can you see it's got a carbon-to-carbon triple bond in it? And ethine reacts with two lots of hydrogen to form ethane. And then in the table, you're told the average bond enthalpy. Now, the reason you're told an average bond enthalpy is because, for instance, the C to C bond in one molecule might have one value, but in a different molecule it might have another value. So you're quoted the average of them, of all the different C to C bonds. Okay, and you've got all of the different bonds that you need here. The first thing I would do is I would take your balanced equation, which is given here, and I would draw it out in full displayed formula where you show all of the bonds. So the ethine is already done for you. You've got the C triple bond C, and then the bonds to the hydrogen, remembering that carbon always forms 4 bonds. And then you've got that reacting with 2 molecules of hydrogen, so that's H to H, and that's twice. Okay, that's your reactants. And then over here I would draw your product. So your product is C2H6, so that's 2 carbons, single bond between the carbons, and then single bonds to hydrogen, like so. So you'll find this much easier to tackle a question like this if you have the full displayed formula drawn out where you can see all the bonds. And underneath that, you don't have to do this, I'm doing it in a slightly long-winded way, but hopefully to make it obvious for you, I would then make a list of all the bonds, because you're going to need it for the calculation. So you've got 2 C to H single bonds, you've got 1 C to C triple bond, and you've got 2 H to H bonds. I'm just breaking it up into sections here. Whereas for ethane, which is the product, you've got 1 carbon-to-carbon bond and 6 carbon to hydrogen bonds. Now hopefully you could see that without having to draw it out like that, but it's probably helpful to get it laid out, especially with more complicated examples. They might not give you the full displayed formulae, especially if it's something you're expected to know from your organics. Okay, and then we're going to start inserting some numbers. So 2 lots of CH, that is 2 lots of 413, which is 826. You've got 1 C triple bond to C, which is 1 lot of 839, which is 839, obviously. And then 2 lots of the H to H, which is 2 lots of 436, which is 872. Is everyone okay with that? Then I add these all together, and that comes out as 2,537. Now that is the amount of energy that would be required to break the bonds of the reactants. So you'd need to put in 2,537 kilojoules per mole to break the bonds of the reactants. That process is endothermic, because breaking bonds requires energy. If you want to break something, you have to put energy into it. And what we're going to see over here on the right hand side is the energy released when we make new bonds. So you've got one lot of the carbon-to-carbon single bond. So that's one lot of 348, which is 348. And then you've got 6 lots of the CH bond, which is 6 lots of 413, which is 2,478. Then we add these together, gives you 2,826. So what this means is we are requiring 2,537 kilojoules per mole to break the bonds of the reactants, and we are releasing 2,826 kilojoules per mole when we make the new bonds in the products. So to work out the overall enthalpy change, it's going to be 2,537, which is the endothermic, minus the exothermic, which is 2,826. And that comes out as minus 289 kilojoules per mole, so it's exothermic. Okay, so just to check you're on the right lines at least, you would need 3.5 O2s to balance it. And then I'm going to draw it out underneath here. So C2H6 is ethane. And then oxygen is O double bond O, but we know that there's 3.5 of them. And then draw a line there because we're going to go to the product. CO2 is C double bond O, C double bond O. And there's 2 of them. And water is H2O, and there's 3 of them. Okay, so what we're saying for this is that delta H equals the reactants minus the products. And we know delta H, because it's given up in the question up here, it's minus 1561. R is what we want to find out because the CH bond is one of the reactants. And then it's minus the products. Now the products are the, what have we got for the products? You've got 2 lots of CO2, so that's 4 lots of the CO bond. So that's 4 lots of 799. Plus, you've also got 3 lots of water, so that's 6 lots of the OH bond, which is 463. So what we can say then is that minus 1561 equals R minus 5974. And therefore R must be 4413. But we're not there yet. This is just a sort of a long-winded way of getting there. There are much shorter ways of doing this, but hopefully that's fairly logical so far. So 4413, which is R, must equal 3.5 times the 495 plus 348, which is the C to C bond, plus 6 lots of X. Let's just call it X, where X is the CH bond. And what we end up with is 6 times x equals 2332.5, and therefore x is this number divided by 6, and it comes out as 389 kilojoules per mole. Did that make sense? Like that? Sure?
Yeah, I did.
I didn't print it on the sheet. So here you've got C2H4 reacting with 3 lots of oxygen to give 2 lots of CO2 and 2 lots of water. And the aim, once again, is to calculate the CH bond. So it's the same style of question. So it's a good test as to whether the last bit has made sense or not. Firstly, I would write out the equation so you can see all the bonds. So C2H4 must have a carbon-to-carbon double bond in it. And then you've got 3 lots of oxygen. So that's your reactants there. And then the products, you've got 2 lots of CO2. Sarah. And then you've got 2 lots of water. And the aim is to calculate this CH bond. So we know that delta H is R minus P. So we can start inserting some numbers now. Yeah, so delta H is minus 1,387. R we're going to get to in a second. And then P is 5056, which is the 4 lots of the CO and 4 lots of the OH. And therefore R must equal 3669. But the 3669, I just make some space, the 3669, which is R, must be made up of the C to C, which is 614, the 3 lots of the oxygen, which is 3 lots of 495, and 4 lots of X, or N, let's call it N because that looks better. And therefore 4 lots of N must equal 1,570, and therefore N must equal 392.5. Does that make sense? So it's quite awkward ones, but hopefully that's fairly logical like that. Well, thank you for taking the time to watch this video. I hope it was helpful. Remember, if you do find it helpful, please like, please subscribe, share with your friends, and please keep coming back for more content. See you next time.